Okay, we're going to find the equation of a secant line, and the secant line is based on a line that is on the curve of a graph. So what I did is I gave you an example here of x squared minus 2. You know what x squared means. That's the quadratic function, and then we shifted it down by 2. So I already plotted this. Now what they're going to want to do is find the rate of change. They want to know what's happening between negative 2 to 1 for x. So they're saying x goes to c, basically. We'll talk about that later. But basically we're just going to do our two x's. So they want to know what happens between, what's happening between negative 2 to 1 for your x. We'll just call this x2, and we'll call this x1, so it's not confusing. So here's what we're looking at, this part right in here. Now what's happening on the y? And we're going to draw the line that goes to that. So the first thing we have to do is find out what is our y. So we're going to first find the slope, or the average rate of change, which we did in the previous video. And we're going to do the average rate of change as delta y, or the change of y, change in y, over the change of x to find the slope, which is f of x. If you want, we'll just call it x2 minus f of x1 over x of 2 minus x of 1. So basically it's just like saying y sub 2 minus y sub 1. It's just like finding the slope like you did in Algebra 1. So we don't know what y sub 2 and y sub 1 is, so we have to evaluate. So the first thing we're going to do is find out what is f of negative 2. Well, f of negative 2 is negative 2 squared minus 2, which equals 2. So our point is x is negative 2, y is 2. So that's the point right here. Make it big, make a big dot. Alright? Now we also have to evaluate f of 1 because we want to see what's happening there. So f of 1 is going to be 1 squared minus 2 equals negative 1. So when x is 1, y is negative 1. So we have our 2 points. We have point 1 and point 2. Or you can call them point 2 and point 1, I don't care. And then we just find the slope. So the slope is f of x, so we're going to do 2, we're going to go do the formula here. Well, we're going to use 0.2, so this is, we'll call this x1, y1, x2, y2. Alright, and just use your formula. So it's negative 1 minus 2 over 1 minus a negative 2. And that gives us negative 3 over 3, which equals negative 1. So that's your average rate of change. Now they want the equation of the secant line. Alright? So what we have to do is we're doing a line which is y equals mx plus b. Our slope is negative 1, so it's y equals negative 1x, so which is negative x plus b. And we're going to plug in one of these points. You can plug in this one or this one. It doesn't matter because both of these points, in fact, we forgot to do this one, lie on the curve there. Alright? And basically we're going to draw a line to connect these 2 points. I'm going to connect these 2 points and then make the line. So that's the secant line. And that's what secant line means. It's the line that you're evaluating between here, -2 and 1. And this is the part right in here. So let's go back in here. This is the part we're looking at right here. All right. So I don't care what point. I'll go ahead and put in maybe 2. I'll put the 2's in. So we have 2 equals negative times a -2 plus b. So 2 equals 2 plus b. So clearly b is 0. And you can see it right here. My y-intercept is 0. Remember, this is your y-intercept. So my equation of my secant line is just y equals -x. Okay? Now, it's pretty easy. The part that confuses most students is this part right in here. But if you just get used to the way they do the notation, it's pretty easy. You're just basically doing Algebra 1. Also, you don't have to graph. I just did the graph here so you can see it. So if we want to do another one, let's do another one. Let's find the average rate of change from, so we're going to let the average rate of change, so delta y over delta x of g from -1 to 2. And our g is x squared plus 1. Now, I'm going to have to graph these real good. It's really hard for me to graph these on the board. So I know this is the 1, and then 1 goes to 1, 2 goes to 4. So from here I'm going 1, 2, 3, 4. And I'll go here is 1, 2, 3, 4. So it's something like this. Whoops, what happened? Sorry about that. Move this back down. What happened to my graph? Anyway, see if I can get it done here. It keeps moving, so I can't move it. I don't know what's happening. Alright, well, let's just start again. So here we go. We have here, here, and goes to 1, 2, 3, 4 here. And then I'm just going to make it symmetric and to 4. So there it is. And I want to find out what's happening. So this is g of x equals x squared, get the squared. Oh my gosh, what's happening here? Alright, let's go back. Alright, x squared plus 1. Alright, now we want to know what happens, if this thing works, between -1 and 2. So we're going from -1 to 2. And we want to find the equation of the secant line. So by graphing it well, we already know that -1, f of -1, really goes to what? Really goes to 2. So we can plug it in. So that goes to 2. And f of 2, we know goes to 5. So we know our 2 points are -1 goes to 2, and 2 goes to 5. Okay, so there's the 2 points. We also know that our secant line connects these 2 points. So there's our, we know it's going to be positive. So we're looking at what's happening between -1 and 2. So we have to find my slope, or the average rate of change. So I'm just going to let this be 0.2, let this be 0.1. So this is x1, y1, and this is x2, y2. And just plug in the formula. So that's 5 minus 2 over 2 minus a -1. which gives me 5 minus 2 is 3, and this is 3. So my slope is 1. Now I'm trying to get the equation of the line, so I know it's a line. I'm going to write y equals mx plus b. My slope is 1, so 1 times x is just x plus b, and I'm going to plug in one of these points. I think I'll plug in this one, because I don't have to deal with the negatives. That's just me. So I'm going to get y equals 2 plus b, so b has to equal 3. So I'm going to plug my b in back to my equation. So the equation of the secant line is y equals x plus 3. Clearly you can see the 3. That's your y-intercept right there. But again, you don't have to graph it, and sometimes you can't because some of the equations are harder. And that's basically all you're doing. And that is all.